Hi, Kifkon. I love Lebanon. It's the only country that you can go to and say hi in 3 languages in one breath. But anyways, it's an honor to be here. Thank you for having me. I was actually born here in Lebanon in 1975. Both my parents are Lebanese. I have family here in Lebanon, aunts, uncles, cousins. I have cousins in the technology field and entrepreneurship field, like XLab, for example. So point is, I have a lot of ties to Lebanon. It's near to my heart. I've been coming here since I was a child, and I'm so excited to be here. But how did I get here? So, like I said, I was born here in '75, and we shortly left right after I was born, about a year after. And we hopped around all over the world, places like Jeddah, Stockholm, Sweden, until we eventually landed in the United States, where I went to college there, and I eventually worked, I got a job at Microsoft. And there, I've been there for the past 17 years, building hardware and software technologies for computers. This is my manager, Panos. You might have seen him present some of our latest products. It's an amazing team. I'm really proud to be a part of it. But today I'm here to talk about computers. Computers are an integral part of our evolution as a society and a culture. They are fundamental to how we meet our needs and desires. I bet you every one of you right now has either 1 or 2 computers on them right now. It's amazing to think about. And the development and formation of new types of computers, such as smartphones, tablets, are important because it allows us to meet those needs and desires with more, and this is very important, specificity, and therefore better. Let me give you an example. He's listening to music and trying to type. You could do it. I don't recommend it, but wouldn't it be better to have a better tool for that activity? And that's what new computing form factors do. Take a look at these interaction technologies over time of how they've evolved. They're not necessarily better than one another. They just do a particular job better. And look at the display technologies on the side. For us, it started all the way back here in Playtable days. This is my baby at Microsoft, where we came up with the concept of a Surface table. It's the first prototype that we built that illustrates this augmented mixed reality happening on a screen. We built a light table. We put a camera behind the screen and a projector. And we were able to see objects and finger touches at the same time. Of course, think about this. This was back in 2001, before anyone really did or broke the market with a touchscreen. And so you were able to put these physical objects down on the table. These objects were barcoded so that the computer could recognize the barcode. This, at that time, we called mixed reality, where we were mixing the physical worlds and the digital ones. You could put cards down on the table, it can recognize the cards. You can use an ordinary paintbrush, or maybe even more importantly, you can have multiple people simultaneously interacting with the computer. It's quite hard. Remember, this was a long time ago. Or, you see this dial? This dial will come back later in my talk. This is a dial that you rotate for interaction. So today, Microsoft has a wide array of offerings. I work across all these products. A lot of my focus is on Surface. It's something that is kind of near and dear to my heart, but I love all these products. And to illustrate that one main motif that I talked to you about in the beginning, I'm going to take 2 examples from our product line. The first one is going to be about pen computing and how it is evolving, and immersive telepresence. With the immersive telepresence, it's about, the idea is about bringing multiple people together in a room that are not even in the room, but they have the sensation that they're in the room, and I'll show you an example of that. So let's start with pen computing. The reason why we care, but first, let me introduce a couple products. The first one is Surface Book. Surface Book looks like a laptop, but it has a very unique feature. This feature has the ability of you can detach the top. And the reason is that you can use it as a tablet. Remember I was talking about before, using the right tool for the right job. So now you have the ability of typing when you need to, detaching the screen, and writing when you need to. That's really powerful. The other product we just launched last week, and it's one of my favorites. I love it in a lot of ways. It has its roots all the way back in 2001. If you haven't seen it, I'm going to indulge you with some pure imagination.
Me.
Thank you. Thank you. Okay, so the reason why we care about pen computing so much and the interactions that you saw there on Surface Studio, only a pen can. A pen is a very nonlinear way of thinking, is very asynchronous, and it's a very powerful interaction media. It's a right part of the brain rather than mostly the left part of the brain. And even so, like for you students out there, there have been several studies that have shown that if you take notes with a pen versus trying to take notes with a keyboard, people who take notes actually retain the information better with a pen than they are with a keyboard. And the reason is you have to actually understand what you're down. You have to interpret it, turn it into symbols, and then put it down on paper. Also, you can represent ideas pictorially, which is quite difficult to do on a keyboard. And so let's talk about this. Let's go a little bit deep to say, how does a pen computing device form factor evolve? Let's talk about the challenges. On the hardware side, let's talk about the fundamentals to be like paper, because that's really what it should be. It should be like paper in order to use it like paper. And then let's use software to make it better than paper. So I'll give you some quick examples. The first is that all the Surface devices are not 16:9, like this screen up here, or like a television or most laptops. It's 3:2. And the reason 3:2, when you start on the outside form factor, is it looks and feels more like paper. So that's really important to actually have. The second part is when you're building a computer with this touch and pen interaction, there's all these layers that have to go on top of the display to sense the thing that's happening on top. Those layers get in the way. And in the olden days, actually, it was really bad. You had this problem called parallax. Parallax is the distance of the pen tip to where the content is, right? And paper doesn't have any parallax. You're interacting with the paper itself. Ink flows out of the pen. When you touch something, you're touching the paper. But I'm touching glass, and the image is underneath the glass. And so one of the things, we were one of the first manufacturers to fuse the entire optomechanical stack of a display to make it super, and where we've gone from traditionally something like 2 millimeters, now we're all the way down to 0.7. And every increment of a sub-millimeter gets you all that much closer. It's really powerful. The second idea is called latency. Latency is the term where it's the time in which it takes a computer to react to your reaction, to your input. When you touch the screen, the computer has to react to your touch. That time is called latency, and we wanted to understand that, so we built this really fast computing device. Of course, paper has 0 latency. So we built this high-speed digitizer, and this is what computers felt like for the most part a while back. About 100 to 50 milliseconds of latency. You saw the square essentially slowly dragging behind the finger. But as we started speeding things up, 10 milliseconds, 1 millisecond, a magic turning point happened at some number there, where all of a sudden felt like instead of having a square following your finger, you were moving the finger. That's very important when you want to create a natural user interface. And so we took some of these ideas and we put them in a pen. And now you can see this digital pen runs at 1,000 times a second, literally flowing out of it. In fact, it just looks normal. But it's not. It is, in fact, a digital computer implementing this technique. And before, again, for the most part, ink was dragging behind, causing you to write bigger and not as accurate. Okay. So those are some of the techniques on the hardware side that we've implemented to make pen feel more like paper, right? A computer feel more like paper. Now let's talk about software. How can software go beyond paper? And the first, so you have an affordance where you can point at an object with your finger and start writing or actually execute a command with your pen. And that's a very natural thing. The thing you notice is Ken is here doing a number of actions, but there's no file menu. And this is very powerful because when you're creating, you don't want to be interrupted by going to a file menu or going to tools. You just want to do, right? The second thing is, I don't know about you, but I have terrible handwriting. But if I'm writing on a computer, why can't the computer learn how I'm writing and make it look better? So we call this ink beautification. We're learning how you're writing, and we can apply it to letters and symbols to make you essentially a better writer. You can see how the computer is essentially fixing the ink in real time. Or we can guess, almost trying to help you complete your drawing, almost teaching you how to draw. Or one of my favorites, if you can imagine what you want, rather than hunting through hundreds and hundreds of stencils, why not just draw what you can imagine and have the computer figure it out automatically? And you can imagine it. Let's say I'm searching for a yellow triangle. Why not just draw it rather than type it in a keyboard? Because you have a very powerful way of communicating multiple degrees of freedom at the same time. Like, I'm looking for a shirt with red sleeves, white in the middle with the black squares, or I'm looking for a picture of the Eiffel Tower from this very specific vantage point in the night with the lights on. Or no, I want it during the day where there's green grass. Because you're communicating the frame of the picture. It's not a picture of the Eiffel Tower from underneath. It's a picture from a very specific vantage point. And so, of course, paper can't make your handwriting better. It can't teach you how to draw, right? And you can't search with paper. So those are some of the techniques that go beyond paper. So that's the first example. And the second example now is on the immersive telepresence. And for that, I'm going to use Hololens and our large touchscreen interaction. So Surface Hub is a super cool device in that it's a really high-performant touchscreen, but that's not its main point. Its main point that is outfitted with cameras, and it's a pillar for a vision that I've been working on for a long time, and it's called the Magic Window. Imagine a wall completely dedicated to video porting you across the world. Here are two kids talking to each other from opposite sides of the world. Their gestures are being sensed both on screen and off screen. But maybe even more importantly, the image that they're sending to the screen as if the two people are standing right there in front of each other. This is the world's first seeing display. This display is able to put an image on the screen, but is also able to capture my hands on the screen and off the screen. And that's really powerful because when the computer can understand where your hand is, what your hand's trying to do, what finger you're using, whether you're approaching it from the left or the right, it can do what we call, it can compute on your behalf. It understands your intent. It understands that you're trying to pick an object across the screen and move it across. That's really powerful, and it's kind of the future of where computing is going, where you have this immersive interaction. But what if you can go beyond the screen? Audio is missing again. Real quick.
Is the world with holograms.
Just leave it on.
This is Microsoft HoloLens.
It is a unique combination of display and sensing technology. So we have built what's called a holographic light guide. This holographic light guide is see-through. You put it on, and you can actually see your world, which is very unique. It's augmented reality happening. And it is able to put what's called holograms out in the real world as if this virtual object exists in the real world. No matter how fast I move my head, that virtual object is literally right there. And that's really true mixed reality happening. So that was like a big innovation on the display side. It's really difficult to do. The second part is the 3D cameras. Hololens has like 6 cameras on it. The 3D cameras are extremely powerful, and we use the power of software to reconstruct the world in 3 dimensions in real time. So here we're walking, and the computer is actually building a model of those books, those tables, those chairs in real time, having that in a database. It's extremely powerful. And if we can digitize a book or a table, we can certainly digitize people. So here we're using room-outfitted technology, 3D cameras, where we're digitizing Sharam in real time. Now the computer has a model of Sharam, and now we're going to create this magical telepresence experience I'm talking to you about. Sharam is interacting with a hologram of his daughter. His daughter is in another room. She's being digitized in real time, and she's being displayed in Sharam's HoloLens as if she's standing right there in the room. She's not there. She's somewhere else, but she's standing as if she's right there. That's extremely powerful, extremely magical. The computer has the ability of storing that 3D information. You can play back that moment in time as a digital memory. So Sharam is actually wearing his glasses, reliving that moment with his daughter. And because it's a digital manipulation, you can manipulate it and put it on the table like a 3D picture frame. Imagine. being able to do that and saving those precious memories. So in summary, I've given you two kind of major examples where new display technology and new ways of interacting with the computer are fundamental to developing new types of computers. This increases diversification of the solution space. It allows you, creates opportunity for you students out there, for you entrepreneurs out there, for your business developers out there to develop new ideas that have never been done before, to be the next great thing. And the thing I promise you is that computer form factors will continue to diversify. If you just look at history, it will not stop. It'll always keep going. And that's something to really pay attention to. Because if you do, and you catch that wave, but maybe more importantly, you might be able to change everyone else's life. Maybe you can change Lebanon. And the world, it could look something like this. Shukran kthir. Thank you so much.